Alright, in this video, I'm going to explain a little bit about the future EPF contribution in the example 7.1. Okay, just now in the first part of the video, I explained about Alan case where the information about the future EPF contribution, if you remember, the amount of EPF future EPF contribution is about 13,800 per year. So in this video, I'm going to explain how you can get this figure basically and why our assumption is actually 5% for the increment of the future EPF contribution. Therefore, if you look back at the question, again, the question given to you is where the annual income is 60,000, okay, and it is expected to increase at an average rate of 5% per annum. If we want to calculate the future EPF contribution, then we have to calculate what will be the amount of salary per month received by Alan. So this 60,000 is an actually income per year. So if we divide with 12 months, we can understand now that Alan received about 5,000 per month. So if we calculate the EPF contribution by both of their employer and employee, 23% times with 5%, which means the contribution of the EPF is 1,150 per month, which is equivalent to 13,800 per year. Okay, so 1150 times 12, we can get 13,800 per year. Okay, so this is our base of calculating the future EPF contribution, that is 13,800 per year, and this is our assumption in our calculation. And given that in the question it is mentioned that this 60,000 is expected to increase at an average rate of 5% per annum, which means that the future contribution of EPF is not static. This 13,800 is not static, it's not fixed. For next year, it will increase. For another year, it will increase at what rate? Because the salary increase at the rate of 5% per annum. So that's why we assume that the EPF contribution also will increase at the 5% rate per annum. Alright, now we look at the example for capital conservation, and as we already discussed before, capital conservation focus on maintaining the original investment. Okay, so the original investment asset will be remain for long period, and at the same time the amount received by the retiree, they will still receive the amount of the retirement income per year. But at the same time, at the end of the in the case of the retiree die, the asset is still preserved. Okay, as for capital conservation, it is very important for us to note that the value of the retirement need to be higher, or at least at the same rate with the inflation rate, because we want to provide the retiree with sufficient retirement income in tandem with the rate of the inflation. Okay, so as for that, let us have a look at the question, example 7.2, the case of Benny. We shall now assume that Benny wished to have a retirement portfolio which can provide annual retirement income which is growing at 5% per annum forever. The first year, okay, now we look at the information. Benny have a retirement portfolio, means that this is the retirement portfolio that Benny has. And this portfolio can provide annual retirement income which is growing at 5% per annum forever. Okay, so the annual income that Benny wants is not static, it is increasing. Okay, so the first year annual income is estimated to be 300,000. Okay, so the first year is 300,000, which means because Benny want to have annual retirement income growing at 5% means that this 300,000 is not static. The first year is 300,000, the second year will be increased by 5%, and so on. It continues. Okay. The following assets have been identified for retirement. So these are basically the information about the retirement portfolio that Benny has. They have here unit trust, commercial REITs, blue chip bonds, fixed deposit, and we can see that Benny is actually very rich, because at this part, at this point of time, he already have around 11 million of asset for the purpose of retirement. It is important to note that the case of capital conservation is very rare, okay, for the client, because not many people on earth actually having this very huge amount of fund for capital conservation. Normally, as a normal human being, the majority of the people will follow the capital liquidation approach. So that's why although this is a very rare case, because not many people are affordable to preserve their retirement fund, but this is something that we have to take into account, because in certain cases it exists. Okay, and here are basically the estimated return for the retirement portfolio. Alright, therefore our task is to check whether this asset actually sufficient for retirement fund, for the annual retirement income of Benny. Okay, so actually because the asset that Benny has is very large, because the unit trust in fund is just is already about 2 million. Commercial property is 2.5 million. Blue chip shares is 2.5 million. If just by using naked eyes, if Benny want to have 300,000 per year, it is not going to be difficult, because let's say unit trust 8%. Okay, if we calculate 8% times 2 million, Benny already has 160,000 here per year from the return from the unit trust only, 160,000. Let's say by taking the example of blue chip shares, 9% times with 2.5 million, he already can have here, around 225,000. So it is very easy for Benny to get this 300,000 per year, because just by using the return from the blue chip shares plus with the return from the unit trust only, we can see that he can easily get actually more than 300,000. So in this case, he is actually very rich. The point is that we want to check whether the required rate of return is some kind like a tally with the rate of return from the portfolio investment. Okay, that is what we want to check on, whether the required rate of return to achieve the capital conservation approach is tally with the rate of return from the portfolio retirement that Benny has. Alright, so what we need to do now is to check the future value of the retirement asset that belong to Benny. So it is very common for us to do, where we have to transform the data in the present value form to the future value by using the information given to us. Okay, so as we look at this question, when Benny want to retire 10 years from now, okay, this is the information given to us. The following assets have been identified for retirement, which is 10 years from now. So N is equal to 10. By using that information, we can calculate for equity fund CMPD using N. N is actually 10 years. I, 8%, PV 2 million, payment is 0. We can get the future value of 4317850. Okay, so we use the same calculation to just replace the amount for return and the present value, then we can get the future value of the asset belong to Benny for the next 10 years. That is when he start to retire. The total asset that Benny has After 10 years, that is during, when he start to retire, is about 21 million. This is a very, very huge amount. And if we want to calculate the lump sum need, what is the lump sum need of Benny? We can use the formula, okay, that is provided in chapter 3. Okay, in chapter 3, there's a formula over there on capital conservation and inflation factors somewhere in the page 313. Okay, this question is related to that particular formula exactly. All right, so the point is because we know that this is actually the return, but we don't know the required rate of return. If we look at the formula for in the case of capital conservation with inflation factors, here is basically the formula. Okay, PV equal to A divided with R minus G, where at this point of time we know that the A, actually the first year retirement income is 300,000. The G, which referring to the inflation, is 5%, and the PV upon retirement is 21 million. Okay, this is the PV present value on the first day of the retirement. Okay, 21 million. So this is the formula for us to calculate the lump sum need actually. So at this point of time, we cannot calculate this because we don't know what is actually R. R is required rate of return. We don't know this figure yet. Therefore, by using the PV of the lump sum required, okay, because we already have this information, the PV of the asset upon retirement, we can try to find what will be the R. Therefore, we have to use this formula and we have to find the R, that is the return required to achieve the financial goal. So once we calculate the R here by using the formula, by manipulating the formula, then we can get R is equivalent to 6.38%. Okay, 6.38%. Okay, if we look back at the chapter 3, all right, chapter 3, capital conservation with inflation factor. Okay, at page 313, if we already have the information on the required rate of return, we can identify what will be the lump sum need at the beginning of the retirement. All right, so let's say we just want to check how much is actually the lump sum need at the beginning of the retirement for Benny. Therefore, we can apply this formula, okay, the same formula that we used before. Look at the capital conservation with inflation factors in chapter 3, page 313. This is the formula, and we replace the value. A is 300,000. A is first year annual retirement income. 1 plus R divide with R minus G. So R we already know that is 6.38 based on this calculation. Alright, 6.38 is the required rate of return. G is equivalent to 4%, that is the inflation rate. Then we try to solve this equation and we can get the lump sum need at the beginning of the retirement is about 13 million. Okay, 13,409,243. All right, so it is pretty high, but the asset that Benny has is also large, so it should not be a problem at all. But now what we want to check is where we want to calculate the portfolio return. Okay, because they have several assets and we want to calculate what would be the portfolio return for the portfolio retirement that Benny has. Therefore, we already calculate the future value. We should calculate the weightings times with the return. Okay, this is another column. So for the future value, this is the weightings is about 0.2. This is for the equity fund is 0.2. For the commercial is 0.24. Rates is 0.08. How we should calculate this? Easy. Just taking this future value, divide with this total 21,757,000. Okay. we divide this, then we can get the weightings of 0.2, 0.24, etc., etc. As for weightings times with return, this is also very straightforward. 0.20 with times with return, we can get the weightings times with return here is 1.59%, 1.78%, 0.49, and the total is 7.23. Okay, so the required rate of return that Benny need is 6.38, but if we calculate the return, okay, from the portfolio is 7.23, which means the return provided by the portfolio is higher than the required rate of return for us to have, for Benny to achieve the financial goal of capital conservation. Okay, so by comparing this, we can see that the asset that Benny has at this point of time provides higher return than the required rate of return. So it should be no problem at all for Benny to achieve his financial goal of the capital conservation during retirement. Alright, so we already understand that Benny needs an increase towards his annual retirement income by 5% per year. Okay, so the first year should be 300,000, and the next year it will be keep increasing by 5%. We also have to understand that as a financial planner, how we can cater for that increment of 5% of the annual income of Benny. Okay, so as I said before, that if we look at the information on Benny, we can see that Benny is quite comfortable. The return from the blue chip shares, the return from the bond, the return from the fixed deposit, you know, it also provides a very huge amount. And if it is invested, again, because he will just take 300,000 per year, therefore he still have a lot of money or cash remaining in the investment that can be reinvested and generate for more income to cater for this 5% increment of the retirement income. Okay, so it seems that by having the assets that generate income, it should be no problem for Benny to achieve his retirement goal. This is just I would like to show you that the income has been increased by 5% per annum. So we can see that the trend is increasing for Benny, and once it reach 30 years of the retirement, he will need around 1.2 million per year. Okay, so as a conclusion, I would like to remind that financial planner must consider many factors in constructing a retirement plan or retirement portfolio for the client, and must be able to be ready to make an appropriate adjustment from time to time based on the economic situation, based on the economic condition, based on the information given to the financial planner itself.